Hello and welcome to our project presentation on sub-event detection on social media. You can download our code base from the link given.
Our project involves making a summary of events from a corpus of tweets which talk about a single major event. The objective of the project is to extract sub-events within the event and give a summary about the sub-event.
So for this project we have followed a two-step approach. The first step is sub-event detection, wherein we identify whether a sub-event has occurred and what tweets comprise that sub-event. The tweet selection process chooses representative tweets that describe the sub-event appropriately. So the aggregation of these processes will provide a set of tweets as a summary of the event. So coming to detection of the sub-event, it is done by finding the distance measure between different tweets of the same event. For this purpose, we have created a dictionary of words which contains every relevant word we can use and the count of the word in the corpus. Next, we create a vector for every tweet. The vector contains the ID of the tweet as well as the count of each word present in the tweet.
Continuing with the same, we have used the LSH library of Python in this module to find similarity distance between various tweets. Each tweet is analyzed and compared with the existing group of similar tweets. If the tweet matches any of the group with a high threshold, the tweet is assumed to belong to that group and is added to it. Otherwise, a new group is created with that tweet as a representative tweet for the group. In the end, all tweets are thus partitioned into groups representing different sub-events. Now coming to the second part of our system, that is summarization of sub-event. For this, we used a statistical weighting technique called term frequency inverse document frequency that assigns each term within a document a weight that reflects its importance within the document. The TF-IDF value has two parts. The TF part, which assigns more weight to the words that occur more frequently because important words are assumed to be often repeated, and the IDF part compensates for the fact that some words such as common stop words are quite frequent. Now after this, the tweets are normalized so that the bias towards larger tweets is prevented. Now here is a block diagram of our system that summarizes the whole workflow of it. So as you can see here, there is a nice little interface for our project. It allows us to run the sub-event detection module as well as the summarization module and displays the summarized sub-events on the screen here. To perform sub-event detection, we click here on the run button, and to do the summarization task after this, we click here. As soon as we click on the summarization button, we see a list of sub-events categorized into boxes, and below each sub-event we have a list of tweets that summarize that event. So here are the tweets and the sub-events they belong to.
We use Python for most of our coding part, and to aid us we use two external libraries. First one is LSH, which we use to find distance between two tweets, and the other one is GenSim, which we use to create a corpus out of the whole Twitter dataset. Now the dataset that we used was obtained from Snow that contained 2012 US general elections tweets. As mentioned, we tested our system on the 2012 US general election tweets data, and the results obtained bore around 60% accuracy as compared to the manual evaluation technique. Now the objective for next iteration is to improve the accuracy by finding a new technique for summarizing the tweets. So this ends our presentation. Thank you for watching it, and don't forget to hit like button.